this Unit 7 Part 2 review. I'm just going to show you the answers for this first section, but explain them as I go, and then some of the other problems I'll work with you from start to finish. Okay, the first one, segment AC, that is from here to here. That is a diameter because it goes through the center of the circle and it has both endpoints on the circle. So AC is a diameter. Line CD. Line CD is this whole line right here, and that is a secant because it cuts all the way through the circle. A line that contains a chord is called a secant. So a secant is a line that cuts all the way through the circle. And you can call this line CD, you could call it line CE, you could call it line DE. As long as you use 2 points on the line, you can name it all those different things. But because it's a line and it cuts through the circle, then that is a secant. Okay. Segment AD is a chord because it's in the circle and it has both endpoints on the circle. So AC is also a chord because it's in the circle and it has both endpoints on the circle. So AC is a chord as well as a diameter, whereas AD is just a chord. Okay. Angle AOB is this angle right here, and that's a central angle because its vertex is at the center of the circle. Okay, angle CAD, angle CAD, that is an inscribed angle because its vertex is on the circle and both sides of the angle are in the circle. So angle CAD is called an inscribed angle. Okay. Arc ADC, that is from here to here, and that is a semicircle because it's halfway around the circle, so arc ADC. Okay, this is ray AE, meaning it starts at A and it goes forever in the direction of E. That is a tangent because it just touches the circle once. If you were to extend this and turn it into a line, it just touches the circle once, so that is a tangent. Okay. Arc BC, as long as they use 2 letters, they're talking about less than halfway around the circle. So this is called a minor arc. So a minor arc uses 2 letters, which means less than halfway around the circle. Segment OA, that goes from the center to an edge of the circle, so that is called a radius. And then number 10, arc BDC. So arc BDC is all the way from B to D, keep going, all the way to C. And that is a major arc because it's more than halfway around the circle. So there's a little vocabulary for you. Okay, then some of these I'm going to work out for you from start to finish. And if you already have them worked out and you're just trying to check your answers, then you can just fast forward through what you feel like you need to fast forward through and see if you got your answers right. Okay, number 11. It asks for the circumference of the circle. So we have a choice. We can either use the circumference formula pi d, or we can use the circumference formula 2 pi r. It's really your personal preference. Me personally, I always like to use circumference equals pi times diameter. I just think it's easier. So if the radius is 5, what would the diameter be? If the radius is 5, the diameter is double that, so the diameter would be 10. So I would put a 10 into the D, and 10 times pi is just 10 pi. And that's the answer. That's the circumference of the circle. The circumference is 10 pi. Now, if you put 10 pi in the calculator, I'm just going to do that for you real quick. I'm going to use the pi button. So second, and then the caret symbol. And if you round that to the tenths, it would be 31.4. So either 10 pi or 31.4. Okay, number 12. This one tells me what the circumference is, and it wants to know the diameter. So I'm going to use this same formula here. I'm going to use circumference equals pi times diameter. When they tell me the circumference is 80, I'm actually going to put an 80 into the C. And then when it asks what's the diameter, that means you want to solve for D. You want to get D all by itself. So I have to get rid of pi. So to undo the smush, to undo the multiplication, we divide. So I divide both sides by pi, because that's what I'm trying to get rid of. Pi divided by pi is 1. Shoop! All I'm left with is d. And in the calculator, I'm going to put in 80 divided by pi. So let me just do that. So 80 divided by pi. And if I round that to the tenths, that would be 25.5. So diameter is about 25.5. And that's your answer for this problem. So 25.5. Okay, number 13. This one is a little bit older. It tells me the radius of a circle is 14 and the measure of arc ABC is 250 degrees. And then it asks for the length of the arc ABC. Okay, I'm going to start by drawing a picture. And I'm going to do my best to try to make arc ABC be about 250 degrees. So let's just look something like this. So A, B, C. So this is arc ABC, and it says that that's 250 degrees. And I want to know the length of this arc. So this is the problem where we set up the proportions. When you wanted to find the length of an arc and you wanted to know the area of a sector, area of a slice of pizza, that's where we set up proportion problems. So you just have to know if you need to know the circumference of this circle or if you need to know the area of this circle. So if I'm looking for the length around this piece of the circle, I need to know the length around the whole circle. What word talks about length around the whole circle? Circumference. So I need to know the circumference of this circle. So once again, I can either use pi d or 2 pi r. Your choice. So if the radius is 14, what's the diameter? 28. It's double that. So the circumference is 28 pi. Okay, I needed that for my proportion. So I start off with how many degrees is the arc. So how many degrees is arc ABC? 250 degrees. Out of how many degrees in a full circle? 360. And then I want to know the length of this arc. That's Mr. X. Out of the length around the whole circle, and we just found the length around the whole circle to be the 28 pi. So this is a proportion where we're comparing a part of something to the whole of something. So 250 degrees out of the whole 360. What's the length of this X out of the length of the whole thing? And that's the 28 pi. Okay, so the way I do this is I ignore my pi and I cross multiply and divide. So I take 250 times 28 and then I'm going to divide by 360. And when I get that, I'm going to round that to about 19.4 and then I put the pi back on. So this is about 19.4 pi. The other way you could do it is by actually putting the 28 pi in your calculator. So I could take 250 times 28 pi, get that answer, divide by 360, and have 61.1, which is the same thing as 19.4 pi if I put 19.4 pi in the calculator, or it's really close to it. It's just slightly off because of where it rounds. So it's just close. So 61.1, or I'll go ahead and put this 60.9 in there. And the only difference is because of rounding things. Okay, so I'm just going to box this up over here. One of those three answers is correct. The 19.4 pi, that's the most exact answer you could give. These two are rounded. Okay, number 14. This one's a little tricky. So it says the diameter of a moon is 2,548 kilometers. Okay, so here's my moon. Remember, the diameter goes all the way across the center of the circle, and that diameter is 2,548. And then it says we have an orbiting lunar station that's circling 32 kilometers above the lunar surface. Find the distance traveled by the lunar station. Okay, so we have this orbiting lunar station circling 32 kilometers above the surface. So we've got this station. It's circling, it's orbiting, so it's going around in a circular motion, and it's 32 degrees above this lunar surface. That means the distance from here to here is 32, the distance from here to here is 32, the distance from here to here is 32, from here to here is 32, 32, 32, 32, which is the radius from this to the outside. Okay, when it asks for the distance traveled by the lunar station in one orbit, it wants to know the distance that this is traveling. What is the distance all the way around this circular orbit? So what word talks about the distance around a circle? Circumference. So I'm going to use pi times diameter, and I actually need to know the diameter of this whole thing here. So if this is 32, oh, I'm sorry, I did that wrong. The 32 is not from there to there. The 32, I'm sorry, is from here to here. I apologize. So from here to here is 32, here to here is 32, here to here is 32. That's not the radius. So the 32 is just from here to here. And so the distance from here to here is also 32. So if I want to know the diameter, I'm going to add the 32, the 2,548, and the 32. So sorry about that. So from here to here is 32, here to here is 32, 32, 32, 32, 32. Okay, so let's just add those up. So let's add the 32 to the 2,548 to the 32, and that makes 2,612. And that's the diameter. And so I just put pi back behind it, and there it is. Now, if we want to put that in the calculator with the pi, then it's approximately 8,205.8. And there's the answer for that. And I'm just going to go ahead and box it up over here instead of putting it over on the left-hand column. Okay, so there are those problems. Now these next ones, I'm just going to show you some of this, and then some of them I'm going to work out. It just depends on how difficult the problem is, I think. Okay, so let's look on the next page. I'm going to start off and I'm going to just show you the answer to 15 and 16, and I'm going to talk you through them as I go. So let's talk about 15. So on 15, where the tangent and the radius meet, that makes a 90-degree angle. So I know this is a 90-degree angle because that's where the tangent and radius meet. I know that this radius has a length of 3, so this radius has a length of 3, which makes this whole segment here 10, because 3 plus 7 is 10. And then it's just Pythagorean theorem. So a squared plus b squared is c squared. So 3 squared plus x squared is 10 squared. And then you can see I worked that out over here. And you get the square root of 91, which is about 9.5. So this one isn't extremely difficult. You just have to know where the radius and tangent meet, that makes your 90-degree angle. And then it's just Pythagorean theorem. And then the other thing that was maybe tricky was this radius is 3, so this radius is 3, making the whole segment 10. Okay, let me show you 16 and then I'll walk you through it. Okay, on number 16, they told me down here that OK has a length of 5, so I put that in the picture that OK has a length of 5. And we want to know the length of KL all the way from here to here. So I started by finding this little piece right here by using Pythagorean theorem. So I did 3 squared plus x squared equals 5 squared. And that gave me an answer of 4. And then once I know that x is 4, then this other piece is 4, making the whole segment 8. Now the reason I know that these two pieces are congruent is because we had a theorem a while back that said if you have a diameter or a radius perpendicular to a chord, it cuts the chord in half. So because of that little 90-degree angle box there, I know that this radius is perpendicular to the chord, thus chopping the chord in half. So those two segments are equal. Okay, now 17, this one's a little more difficult, so I think I'm going to work this one out for you from start to finish. And if you already have it done, then you can just fast forward me if you want. Okay, so number 17. It tells me that AK has a length of 8. So AK from here to here has a length of 8. And it wants to know the length of SC. So SC is this whole segment here. It's the diameter of the circle. So if I knew the radius, I could double it and I'd have the diameter. So let's see if I can figure out a radius. Okay, I am actually going to blow this triangle up off to the side, triangle OAK, so I can have a little more space to work. So here's triangle OAK. Now I know that this is a 90-degree angle because the other side is 90. I know that AK has a length of 8 because they told me that right here. And I know OK is a radius. So if I could figure out the radius, then I'll know the diameter. So OK is what I really want to know about. Okay? Okay, now this 30 degree is here for a reason, which means this arc is 30 degrees, which means this central angle is 30 degrees. Remember, whatever a central angle is what the arc is. So if this arc is 30 degrees, this angle is 30 degrees. That means this is a 30-degree angle right there. So if that's 30 and that's 90, what's this guy? 60. So we have got ourselves a 30, 60, 90 triangle. So here I go. Across from the 30, I label that with x. Across from the 60, that's x square root of 3. And across from the 90, that's 2x. Well, every time we get done labeling, we have to know what our x is, and do we? Yes, we do. We know x is 8. So if x is 8, I'm going to put an 8 in this x. 2 times 8 is 16. So OK has a length of 16. So let me put that over here. OK has a length of 16. So that's a radius, which means from O to S is a radius. So that's 16. So what would the whole diameter be if you know that the radius is 16? The whole diameter would be 32. And there's your answer. And I don't even care the length of segment OA. But if I did want to know what it was, x is 8, so I'd put an 8 right there, recopy the square root of 3, and that's how long OA is. It's 8 square root of 3. Okay, that one was a little more difficult, so I actually wanted to work it out from start to finish. And I will do that on some other problems to come. Okay, let's go back to the ones that I think are a little bit easier that I can just show you the answers. Okay, let's start with 18. This one is super easy. So this is about two tangents. If you have two tangents that come together at some exterior point, then these two segments are congruent. So I just set 62 equal to 7x minus 8, solve it, and that's my answer. Okay, number 19. This was the last lesson that we just learned, and this is about two chords. I have a chord and a chord, so when you have two chords, the formula is piece times piece equals piece times piece. So the piece of this chord is 4 and x, and the pieces of this chord is 8 and 7. So 4 times x, 4x, 8 times 7, 56, divide by 4, and you get your lovely little answer of 14. So we just learned about this one the other day. So this is the formula for two chords. Okay, this next one is the formula for a secant, because it cuts all the way through the circle, and a tangent, because it just touches the circle once. So this is a secant and a tangent. So when you have a secant and a tangent, we use the formula tangent squared equals whole times outside. So the tangent is 13, so 13 squared equals this whole length of the secant, which is x plus 4, times the outside piece, which is 4. And then I distributed the 4 to give 4x plus 16. I squared the 13 to get 169. Then you would subtract the 16 and divide by 4. And you get your final lovely answer of 38.25. Okay, let's move on. 21. This we learned not too long ago. This was when we were learning about our in, on, and out. So this angle here, its vertex is out of the circle. So since the vertex is out, the formula for finding the angle is half of big arc, 1/2 of big arc minus little arc. So I found the big arc by adding the 160 and taking that away from the 360. So that's how I knew that the big arc was 200. and then you subtract the little arc from it, which is 60, and then you take half of that. So this came from our in, on, and out lesson. Okay, 22. This isn't really something that we did here. It's just a matter of you kind of working through it and thinking about it. If this is a regular hexagon, then it's got 6 sides, and that means that all of these arcs are going to have to be the same. So I just took 360 and divided by 6, and that makes every single arc 60 degrees. And that's only because it's a regular hexagon, where all sides are the same length and all angles are the same measure. Okay, this next one I am going to work out step by step because it's a little more complicated. So let me put this one away. Get the blank one back out. Okay, on 23, I'm looking for x. So first of all, this is a radius because it goes from center to edge. This is also a radius right here because it goes from center to edge. So how long is this radius? 12. So from here to here is 12. If you know that this little chunk is 5, what would this little chunk right here be? 7. Okay, we had some problems throughout this unit where we had to draw in a segment to actually work it out. So I'm going to draw this segment right here, and I'm going to work with this right triangle to find Mr. X. So, is this something we know about? Yeah, this is a radius too. It goes from the center to the edge, so this radius is also 12. And now it's just Pythagorean theorem. So it's not that big of a deal, it's just a matter of you knowing to do this. So Pythagorean theorem would be x squared plus 7 squared equals 12 squared. And then I want to move my 7 squared, so I subtract 7 squared from both sides. And I just put it in the calculator just like that. So in the calculator, I take 12 squared minus 7 squared, and then that makes 95. And then to get rid of that pesky little squared, I have to square root both sides. So I'm going to take the square root of 95 in the calculator, and that makes x approximately 9.7 if I round to the nearest tenths. And that's our answer for Mr. X. Okay, I'm going to go back to, no, maybe I'll do the next one by hand. Okay, 24. Okay, here we go. This is an inscribed angle because its vertex is on the circle and both sides of the angle are in the circle. We learned if an inscribed angle intercepts a semicircle, then this is a 90-degree angle. Or you can just think of this angle, the vertex is on the circle. So when the vertex is on the circle, the angle is half the arc. So half of 180 is 90. Okay, so that was important, knowing that that's 90. Now, if these two angles are the same and all three add to be 180, what do both of these have to be? 45. This is a 45, 45, 90 triangle. Okay, so here I go with the labels. Across from the 45 is x, across from the other 45 is x, and across from the 90 is x square root of 2. Well, do we know what Mr. X is? Yep, x is 4. So if x is 4, then this is 4 square root of 2. And that's what they wanted for JL. So JL is 4 square root of 2. Now, if anybody happened to put that in the calculator for some reason, it's approximately 5.7. Okay, when it wants to know the circumference, remember that formula is either pi d or 2 pi r, your choice. And isn't 4 square root of 2 the diameter? Yeah. So it's 4 square root of 2 pi. And if you put that in the calculator, you could get about 5.7 pi, or if I put 4 square root of 2 pi in the calculator like this, then I could get about 17.8. So one of these, they're all the same. 4 square root of 2 pi is, of course, the most accurate answer you could possibly give me, because the 5.7 is a rounding of that. Okay, 25. Okay, a couple things. I have a radius perpendicular to a chord. So it's going to chop this chord in half. Now x is all the way across, but this little piece will be the same as this piece. And 25 is a radius because it goes from center to edge. I'm going to draw in another radius from center to edge. So this radius is also 25. And now I can do Pythagorean theorem to find just from there to there. So I'm going to call this, I'll just call it A. How about that? So I would have A squared plus 7 squared equals 25 squared. Oops, sorry, I can't see that. So from here to here I called A, and then I did A squared plus 7 squared is 25 squared. I'm going to move the 7 squared by subtracting it. And then when I do that, let me just put that in the calculator so you all can see it. So I'm going to take 25 squared minus 7 squared. That makes 576. And then to get rid of the pesky little squared, I have to square root. So in the calculator, I'm going to take the square root of 576, and that makes A 24. Okay, so remember, that is just from here to here, which is the same thing as from here to here. So Mr. X is all the way across, so Mr. X would be 48. Okay, the rest of these I think are easier, so I'm going to go back to showing you the work already done and then just talk you through it. Okay, 26. Should look something like this. So in this angle, the vertex of the angle is outside of the circle, so we do half of big arc minus little arc. The big arc is Mr. X, the little arc is the 30, and 45 is the angle. Okay, now what I didn't show is how I got rid of my 1/2. So the way I got rid of my half was I multiplied by the reciprocal, so I multiplied this side by 2 over 1, making those go away, and I multiplied this side by 2. So 2 times 45 made the 90, those canceled out, the x minus 30 just dropped down, and then I added 30 and got 120. Now you might have worked this out slightly different and got the same answer, which is perfectly fine. Different ways to do different things. But the vertex is out, so it's half a big arc minus little arc. Okay, next one up. Number 27. So this time we're looking at an angle whose vertex is in the circle. It doesn't quite look like it's at the center. So I said in, so it's half of arc plus arc. And so the arcs that we want to add together are this arc right here and this arc right here. So the 55 is the angle, so I put that into the angle, equals half of the x plus the 80. I did this like the last one. I got rid of the 1/2, so I multiplied this side by 2 over 1, gone, leaving the x plus 80. And then I multiplied this side by 2, which made the 110. And then I subtract 80 and I get 30. And you can always distribute the 1/2. There's nothing wrong with that either. I just like getting rid of the 1/2 by multiplying by the reciprocal. Okay, on this one, we are looking at an angle whose vertex is outside of the circle. So it's 1/2 of big arc minus little arc. I just had to find the big arc by taking 360 minus 125, and that's how I found the big arc to be 235. Subtract the little one and take half of that. Very simple. Okay, 29. This time we are looking at an angle whose vertex is on the circle. So when it's on, the angle's half the arc. So my angle, 4x minus 5, is half of the arc, so half of 130. I went ahead and I took half of 130 and got a 65, and then I just solved that equation. So there was a little practice of our in, on, and out. Okay, let's look at number 30. Number 30, we learned this not too long ago. So we learned that if two tangent segments meet at some exterior point, that those two tangent segments are congruent, so that's why those are both 7. That's why both of these are 3. And then these two are going to equal as well. So I solved that equation where I set those two equal. Once I got my x to be 4, I plugged it in and I found each of those to be 13. So x is 4, And then to find perimeter, you just add up all your sides. So I added the 20 to the 10 to the 16, and that gives me my perimeter of 46. Okay, so this is about two tangents meeting at an outside segment, so those two pieces are equal. Those two pieces are equal. Those two pieces are equal. Okay, number 31. This is another practice of what we were doing a minute ago. The vertex of this angle is on the circle, so the angle is half the arc. I know that this is a diameter, so it's 180 from here to here, so that's how I knew that this was 100. So that's the arc I want to use. So x is the angle, it equals half of the 100, so x is 50. Okay, and then 32. I'm going to let you look at this for a second. This guy you might have forgot about. So I set them equal, I solved it and got 6. That part's easy. It's just, do you remember why I set them equal? And the reason I set them equal is because this angle is an inscribed angle and it intercepts arc RS. Well, if you look at this angle, it's an inscribed angle also, and it also intercepts arc RS. We had a theorem that said if you have two inscribed angles and they intercept the same arc, then those two angles are congruent. So that's how I know this angle right here is congruent to this angle right here. So that's why I set them equal and worked it that way. Okay, we have the whole back side to talk about, which is going to take me a little bit. So I'm going to stop here. The first video is going to be over the first 32. I'm going to make another video, and it's going to be over the very last page, because that's going to take a little while to explain. So thank you for listening for the first 32.